Hi, everyone. My name is Tom Gilmore, and I'm here to walk you through a coding interview. This will cover two coding questions, a warm-up and a real possible, more complicated coding question. It's going to take approximately 30 minutes to get through all of this, so just to be prepared. And it's not just going to be about solving the problems. It is going to be about what to expect in an actual interview situation when you're sitting in the room with the interviewer, the kinds of things that you need to be aware of, and things that will help you get through it without too much stress, hopefully. The other thing is that this will be completely unfiltered and unedited, so I may make some speaking mistakes as I go along the way, and so please forgive me. This is just for me to not have to go back and do a ton of editing and do a lot of takes. So, because in the classroom, guess what? There are no multiple takes. Everything happens live. So, without much ado, let's get to the task at hand. When you go into an interview, you need to understand the context of what's being expected of you. The interviewer is going to expect you to do certain things, and sometimes it's hard to understand what those things are. In the context of a coding interview, they're going to expect you to ask clarifying questions. They're going to expect you to talk through your strategy for the optimal solution. They're going to be expecting you to be honest and tell them that if you've seen the problem before and that you're not misrepresenting yourself in some way. And they expect you to do the first problem likely within the first 10 or 15 minutes of the interview, which can be daunting. They also expect you to write code that is readable, understandable, and that anybody would be proud of in their actual, day-to-day coding activities. So what's going through the interviewer's mind when they are interviewing? What kind of questions are they trying to get answers for? Understanding what they're looking for is going to help you give them what they're looking for. And here's a list of a few things. Are you able to explain your reasoning? Can you perform in a fast-paced environment? How quickly you can solve these problems is going to be indicative of that. Are you good at solving problems quickly? And do you ask relevant questions that you don't just go quiet and say, here you go, without asking first, well, what exactly are the parameters that you're trying to solve for, and why are you doing this? That speaks to collaboration within a team, and or collaborating with customers, people who are asking you to do these things. And they're also asking themselves, would you be a good fit on their team? If you came in, how would you get along with everybody? Would you be, they're expecting everybody that they interview to be somebody who could just jump right in and feel like they're part of the team. And then, of course, they want to make sure that you're being genuine and that everything you say is completely honest, and that you're not trying to misrepresent your skills in any way. They can sniff that out very, very, very quickly. So just to keep in mind when you're going through the interview. Now, the problem we're going to start with is to sum. It takes an array and a sum value, and you need to repair all the pairs of integers in an unsorted array that sum up to the given number. So, for example, if you have here, the num array has these numbers, and you add, how many of these numbers add up to 12? So like 5 plus 7, 3 plus 9, and I think that might be it, right? Well, we can always figure out what the actual answer is after we run the code. The sample output would be something like, all right, 7 and 5, 9 and 3, and then whatever else if it's a longer array. Now, keep in mind, this is what, in the interviewer's head, this is what they call a warm-up. If you spend the entire time working on this problem in your interview, you're going to perform below par as with everybody else. This shouldn't take very much time. So the strategy for the 2-number sum, which is the warm-up, you might want to lead with, if you know it, you might want to lead with, hey, I know this problem. That shows that you're being genuine. You walk through it and say, you solve it this way. Here's the diagram. Here's the code. And you do so as quickly as possible. Because if you know this problem, you know that it's not very big. It's not a large number of lines of code. But if you've never seen it before, or if you've never really practiced the solution, seek to understand the problem and say, well, clarify with them and say, this is how I understand the problem. It's that, can I just assume these things? And, we don't have any edge cases. Do we have to do error correction or whatever? It should be very quick. You want to draw out what your strategy is on the whiteboard. And once you have that all completed, then you're going to want to write the code. After you've written the code, if you're not sure that it's optimized, look at it and say, I think we can optimize it here. Maybe we should do it this way. Maybe we should use this other data structure. And then move on to what the reviewer thinks, the interviewer thinks. And be open. If they ask you, do you think it could be optimized? The answer is pretty much always, maybe. Yeah, I mean, I can't think of it right now, but maybe it could be optimized. Maybe we could put it into a single lambda expression, or maybe we could do something else completely different. But I can't think of it right now. Knowing that what you have is probably optimal, right? Never stick to your guns and say, this is the most optimal code ever. That doesn't usually go over very well in an interview. So let's visualize this strategy. We have a number of array. We have a sum value. We could loop over the array for each item, which means that we'll have to do it whatever the size of the array is times the size of the array, which is n squared, and which is not extremely efficient. So there is a trick to this. There is a trick to this problem, and it's not a very big trick. It is something that when you're coding, you find little things like this to be more efficient. Rather than looping over each item and then looping over each sub item, you might want to instead say, well, my strategy is that I want to take the first item in the array, subtract the 2, and then check to see if the value exists in the array without having to loop. Well, how do we do that? And then if that satisfies that condition, then just move it into the output sum and then move on to the next one. 12 minus 1 is 11. Nope, it doesn't. There's no 11 in there. 12 minus 7, 5, right? So then we might have duplicate sets in there if we start with if we're starting with something that can do that. So the other tool in your toolbox that we can use to turn this into a reality is, if anybody can guess, if this were a live training, I would ask for suggestions. What would I do to be able to look up directly without having to loop over the array? Well, the answer is don't use an array. Use a hash map. A hash map allows you to go straight to a key and look up the value directly without having to loop. Is there an 11 in here? No. We know that because if we went to the hash map and looked for 11, it would be undefined. But if we go here and we say, all right, well, if we pass in 5 and then we're looking for a 7 and 7 exists, boom, we know immediately. So this is how we can do things without looping or making, more recursive call, or not recursive, but nested looping or anything like that. You want to avoid nested looping as much as possible, and the caveat being as much as possible. So what does the code look like for this? So we start with a hash map, and output sums, which is our output, array. And in this example, I'm using Dart. And Dart is a little bit different. This is formatted a little oddly, the output sums down there. Sorry about that. So for the num value in num array, we're going to loop over the entire array. And instead of creating our hash map first, we're going to create it as we go along. It's a time-saving technique. You might start off with, let's fill the hash map first, and then let's loop through it, and then look them up as we go along, which means you'll end up with some duplicates and maybe some extra cycles that you didn't need. The way to optimize that would be to create the list as you go along, as in the solution. And so if we were to walk through this, for each value in the array, we're going to look at the other sum, which is the sum value minus the value in the array, just like what we saw in our diagram. So this would be 12 minus 5. If we haven't created the hash map yet, and everything is blank, then that's not going to be there. So if the hash map other sum toString is undefined, then you know what? It's not equal to undefined. That means it's there. We're going to add it there. But if we have an empty hash map, then it's not going to be there. And so it's actually, we're just going to add the value, the num value, to the hash map. And the next, when we hit that other value later, then the 5 will be the other value. So let's see what that looks like. So if we start off with nothing, and then we're not going to find 7. But by the time we keep adding these things in here, we get to 7, then we're going to be looking for 5, and 5 exists. And then when we find 5, it's going to pop it in. It's going to pop it into the screen. All right. Oh, technical issue with my mouse. All right. So this is the code. When we get to the hash map and the num value, if we find it, we're going to add it to the output sums. And then once we're done looping through it, then we return that output sums. And then we do the calculation. How efficient is this code? What's the big O notation for this? And for this one, it is linear because we're only looping over the array once, which is pretty darn efficient. I don't think we can get any more efficient than that. The number of items in your array. Better code, maybe. Optimal, what kind of things could you fix? Well, maybe I don't need so many comments. Maybe I need to rename my variables to things that are more in line with what they mean. Maybe I could put it all into, like I said, a lambda expression and just do 3 lines of code or 1 line of code. So there's different ways of doing it. Always be open to criticism of your code when you're doing this. Sticking to your guns and saying, I'm the best, I'm the best, I'm the best. It means that you're not going to get along well with your team. All right. So that was easy. That took 10 minutes, right? So now you think, well, now the rest is, what do you like to do for fun? Well, no. Hold on a second. That was just a warm up. They have a bigger problem for you to make sure that you know what you're doing. And depending on the area that you've applied for, if you've applied for a tools position or a data position or a mobile position, they're going to have bigger problems that relate to the kind of work that you're going to be doing. And so let's just say, for instance, that this is for a tools organization, which is what I was part of. I've chosen this problem, build order, because I have seen this in my career. And when I first encountered it in my career, I didn't know what a topological sort was. I had to come up with it. And so I'm intimately familiar with build order, with this problem. It is fairly complicated in logic, not in implementation. The implementation is pretty small. I think my first implementation of it was like 10 lines of code. But for this one, we're going to do it more in an object-oriented kind of fashion, so that we are, that we're following best practices. So the build order problem, I pulled this from the Cracking the Coding interview book that everybody has, obviously. Everybody's bought it, everybody's read it, and this is actually in there somewhere. And I thought, wow, this is a great one. This is very relevant. And what I realized is that the solution in the book is probably a lot more complicated than what it needs to be for an interview. Because really, we're looking at now, we're 10 minutes into the interview or 15 minutes into the interview. We have maybe 30 minutes left to do coding. And keeping that in mind, this is the one that you really have to shine on, and that you really have to show how can you explain your logic? How do you solve a problem? What's going through your mind while you're doing that? And you need to be very communicative with your interviewer to do this. So let's start with, how do we approach this in an interview context? We seek to understand the problem. Ask your interviewer, what are the boundaries? What are the things that I need to know in order, what are the things that I need to solve for? What are the things that I can ignore? What are the things that that I can just sort of forget about, just so that I can do this quickly within the allotted time? The next thing you want to do is visualize the strategy. This will be whiteboarding and putting together the pattern and being able to identify the pattern and say, it's this kind of algorithm. And then from that is, well, let's break it into smaller pieces. How do these little visual items turn into code or into logical bits? And then once you have all of that figured out, then you need to write the code. And writing the code should be pretty straightforward at this point. You need to get through it. And then after that, it's how do you optimize? How do you refactor? How do you calculate the big O? And I'm going to take a guess on the big O for this one, because I was trying to figure it out earlier today. And I thought it was the one that's in the book. I'm not sure is correct. I looked at it in the book. I'm like, it's missing something here. I don't think it's exactly what it is. So we'll talk through my reasoning behind that. But topological sort is going to be the algorithm. And so when you understand when you try to understand the problem, you need to understand, why is build order important? So this is so that you can get the context of what the person asking you to do this it needs to get out of it, and what is it solving for them? Because you could write a solution that doesn't solve what they want you to solve. It means that you are customer focused, that you care about what the customer wants and needs. You have to understand kinds of data that will be passed in. Will it be good data? Will it be bad data? Oh, it'll be good data. Don't worry. What could go wrong in this thing? Do I need to expect a dependency graph that is going to loop in on itself and potentially cause an endless loop, cyclic dependency? What other things do I need to worry about? How complicated do I need to make it? How do I know if it works? For this one, we're just looking for a to Z linear build order. We're not necessarily, we don't need to worry about multi-threading or things like that, right? Potentially. Those are the types of things you need to clarify. Clarify them very quickly. When you get to the visualize the logic, this is where you draw on your whiteboard and you say, all right, what does this look like? If you know what a topological sort looks like, this is the picture they typically show you. A bunch of nodes with arrows pointing in every single direction. A topographical sort is useful in a lot of scenarios, not just tools, but say if you go into a social networking application, all your friends of friends, your friends of friends of friends, your third degree friends, 4th degree friends. These are the types of things that that you need to be able to sort and say, well, if I start here, you know, how do I branch out? How do I sort this stuff? Excuse me. So let's strategize. What do we need to build? What do we need to build to manage this information? What is the data structure that we should use? How should we define our objects? Speak these things out loud. It's like, well, I'm thinking I'm going to use this. I'm thinking this is a topological sort, and so we need a graph object. We need a project object that the graph can manipulate. And then we need our builds object, which has all of our main functions in it. So, how are we going to process the information? Well, with the topological sort, it's pretty straightforward. If you already know it, it's still not easy to sometimes get an idea. But once you understand it, you can put it into the context of what you're doing. So for this particular context, we're looking at projects that we have a project that has an upstream dependency. And that upstream dependency needs to be built before the downstream dependency. So A has no upstream, so we can build it now. C has no upstream, so we can build it now. G has no upstream, so we can build it now if we wanted to. D, F, and E have, well, D and F have A as a dependency, and F has D and A as a dependency, and E has C as a dependency. And so what we want to do is somehow tell F, D, and E that we've built these things. And so we need to essentially add them. I apologize for my for my bottom screen. Once we move these things into the build order output, we need to tell the dependencies in the downstream that their upstream is gone and that there's no more dependency. And so we can say, all right, these have no more dependencies. Now let's process these. And then same on until we are done going through our list. And we know we're done when the build order output is the same size as the number of projects. So the other thing is that if you get here, and let's say there's a cyclic dependency somewhere, let's say H depends on B and B depends on H, then these will not move forward. They will stay stuck. And when it's stuck in one loop, when it's stuck at one point, it will never unstick, which means that you have a cyclic dependency and you can throw your error and say, we're done. So there's the strategy for this. So it's fairly complicated, but it's not unreasonably complicated. If you understand the basics of it, then we have to start looking at, well, what do our objects look like? We need to start at our most base unit node, which is going to be the project itself. The project has an ID, and it has a dependency count. In this case, I've decided I want to set it as an actual number so that I don't have to calculate the number of dependencies in the list. I have upstream dependencies, which is the upstream dependencies tell me who has to build before me, and my downstream dependencies are the ones where I say, well, which projects need me to build first before they can build. We need both of these. When we process these upstreams and downstreams are what we're going to call edges. If you're familiar with topographical sort, an object will have edges, a top edge and a bottom edge. And what we're doing here is we're defining those. We're saying these are edges, and you can link two edges together like if you have two projects, you would add one project as the upstream to the downstream project, and you would add the downstream project to the upstream project. And then you've defined that. And so the kinds of actions that we're going to need to do is we're going to need our getters, right? What is the dependency count? What is the ID? We also are going to need to add and remove upstreams and potentially add and remove downstreams. I found out by the end of coding this that I really didn't need to remove the downstreams. So I just left it out. But it doesn't mean you shouldn't do it, because you may need it at some point. So the other object you're going to need is the graph. And the graph is going to manage your projects. So when you are going through a list of project strings, IDs, you're going to want to turn those into nodes. And then you're going to want to link the edges together, the edge of this project to the edge of that project. And once you do that, you've created a relationship in the graph. And the graph object is we're just going to keep it vanilla topographical sort. It doesn't have to have any business logic other than, create a node, add the edges. That's it. We don't need to go beyond that. All right, so let's start coding. Now we know that we need to create a method called find build order, and this might be in a class called build tools or build helpers, or however you want to talk about it, because it's going to help us build stuff. When we do find build order, we're going to get passed in projects and dependencies. The first thing we want to do is build the graph that has our dependencies in it. And the next thing we want to do is order the projects and do the search. And then the reason I separated out dependencies and projects, you could slap in the projects at the very beginning. It's kind of unnecessary. I was able to optimize it. It just makes it a little more complicated. You have to build another function that does that for you. And in any case, if you're trying to do a breadth first search as opposed to a depth first search, then you might need that. You might just need to say, give me everything that does not have a dependency, and put that into my build first. And it doesn't matter. And if we talk about breadth first versus depth first, what I had shown you up here is this is a breadth first approach, right? Because you're talking about going across the ones at the same levels and moving downward. But what we're going to end up implementing is a depth first, which is going to start with A, and we might be able to get in C because it's in alphabetical order, and then we might hit D before we hit G. And so when we get here, A will no longer be a dependency. So then it'll say, you know what? Go ahead and add D and E and F before you get to G, and then you can add G. And so this is what I found out when I ran my tests. And I said, oh, wow, I'm doing a depth first sort, which is fine if you're doing it as that. If you are doing it for multi-threaded purposes, you might want to do something completely different. All right, so let's create the project class, and it's going to be pretty much like what our diagram said. We have an ID, we have a count, we have our upstreams, and we have our downstream objects. We have a constructor that shows us that when we instantiate this with an ID, that we set the ID, and the underscore in Dart indicates that it's a private variable. So we're not exposing that outside the scope of the class. So then we're creating getters for all of these private variables and getting the downstreams. These are the things that we really need to have in order for this particular thing to work. After that, we're going to have our methods, which are going to add an upstream node to the project object, and we're going to be able to remove the upstream node so that we can record, when things are being added or removed. When we add them, we increase the dependency count. When we remove them, we decrease the dependency count. Rather than getting an upstream stop length, it's a little extra calculation. So maybe just having a straight number to go to would be a little bit more efficient. Just a tad. And then adding the downstream is when you're creating your graph and you say, hey, I need to add the downstream so that I can tell the downstreams when to remove the upstream. And we need to create a graph class. And this is, like I said, your vanilla topographical sort. You have a hash map called project map. And that's going to be made up of string and project. The string is going to be the project ID. And and this is how we're going to manipulate the information inside of the graph. So the hash map. So the getter create node will create a unique, for each ID is going to be unique. If the node is already there, then just return the node. Don't create a new one. If it's not there, then create it. And then we do the edge where we cross-link we cross-link the upstream and the downstream. So we go, hey, upstream, add this downstream as your downstream, and downstream, add this as your upstream. This is your dependency. And now for the main sort routine. So the order projects, we're going to start with the variables. We're going to create a process list, project order, which is going to be the output. We have a temp list for purposes that we are going to use to sort of manage our, to help us optimize our processing and to be able to not duplicate any data inside the project order. And then we have the total projects to let us know when we're going to be finished. And we have start size to help us figure out if we're in a cyclic dependency. We'll show you that as we come along here. Here's the main while loop. While loops kind of freak me out a little bit, but in this case we need one because we don't know how many times we're going to be going over these projects. We could have really complicated dependencies. And so it could take a while. So while the project order length is less than total projects, the project order is the output. We're comparing it to see, do we have the same number of projects that the total number of projects is? If we do, then we're done. That's how we know when we're totally finished. And then we can return the project order, which you see at the bottom here. Before we loop through, we want to say, hey, before we loop through the projects that we're going to process, what is the start size of the project order? If it's 0 right now. After the loop, there should be some stuff in there. It should be 1 or 2 or 3 items in there. And so we say, hey, if the length is the same as the start size, then we know that nothing got added, and we're still, we're still stuck. We're never going to get out of this while loop. So then, return, throw an error or return nothing, or however you want to handle that. And then, but if that's okay, if we're not in a cyclic dependency, then we're going to want to, inside this to do, which is loop through each project in the process list, we're going to generate a temporary list that says, these are the things that we're going to need to process going forward. And the temp list is going to be equal to, we're going to reset it to 0. And let's see what that other code looks like. So here's what it looks like when we loop through each project of the process list. So we do a for loop for all the project ID in the process list, we're going to set the current project to the current project ID, and we're going to go into the graph object and grab the node, and then we're going to see if it has any dependency counts. If it's 0, then add that node, or add the ID to the project order output, and then remove all of the dependencies, remove that particular project ID from all the downstream dependencies. Excuse me. When you're done, just go through and we're not adding it to the process. We're done processing it. But if the dependency count is greater than 0, then we need to process it again, because you know what? It still has upstream dependencies. So then we add that to the temp list. And so when we get down here, project list equals temp list, it'll loop through it again. It'll go through the while loop, and then the process list will have all the stuff that you haven't processed yet. Eventually, that whittles down to 0. Could do it 1 project at a time or 5 projects at a time. It just depends what your graph looks like. All right, now that's a solution. So, how do we calculate the big O notation for this? And this is where I had problems with this, and because I looked in the book, and the book said projects plus dependencies, O P plus D. And I'm not sure if that's correct or not, because if that were the case, then we'd only be looping through it with the number of projects and the number of dependencies. But we may be looping over these dependencies multiple times. So if everything is dependent on each other, except for the top ones, say maybe the worst case scenario might be projects times dependencies plus dependencies. But it's going to be the worst case scenario. It's not going to be the actual case scenario. So in any case, so that is this is me walking through a complicated scenario. What is next? So what comes after this point? Well, if you have time, they're going to see if you have any questions for them. If you have questions for them, only choose questions that you really want to know the answer to. I can't tell you how many times in an interview, excuse me, as I said, this is unedited and unfiltered. If you ask them, if you have stock questions that you don't care about the answer, you're not going to listen to the answer, and you're not going to ask follow-up questions. And so I've sat there waiting for, people asking me questions. They might as well ask me, what's the capital of Georgia? Or how many feet in a mile? It's like, they don't really care about the answer. They just want to have a question that they want an answer to. And then as soon as I answer it, they want to move on to the next question. What you want to do is be genuinely interested in what the team is doing. You want to be interested in them, the work that they're doing. See if you can find common interests with your interviewers, and say, hey, I'm interested in this too. I think this would, I love solving these types of problems. I like, this sounds very interesting to me. And you show an interest for the job. You show an interest for the subject. You're listening to your interviewers, and you're respecting what they're saying. And so then the interview's over, and then somebody else comes and does a completely different section. And this goes on all day. So I will end it here. Thank you very much for listening, and I hope this is educational. And I will follow up. Thank you.